running from University of Oulu. Now, the job that I was given by Jari was to talk a little bit about 6G, what it might mean, what it's not, and I have prepared a slide set for you. So let's start. First of all, there is a certain kind of timeline for 5G. 5G release 15 was released 2018, and release 16 is coming out approximately now. And there are future releases for 5G coming up every 18 months, give or take. Obviously, this COVID-19 situation has slowed down also the standardization process, but still 5G continues to evolve over the next 5 to 10 years, definitely. And we do not know what are the features that will be eventually in 5G. We already know the release 15, which is targeting the enhanced mobile broadband, so basically 4G with steroids. Release 16 is targeting this ultra reliable, low latency communication capabilities of 5G, thus bringing in lower latencies and more reliability. And release 17 is targeting then this massive machine type communications. But for us in the research field, and this by no means is intended to steal the thunder from 5G. We all know that 5G is being deployed globally. Some countries are further ahead than others. Some have not even started yet. So the 5G deployment is just about to start. So therefore, we do not wish to steal the thunder from 5G, but we already recognize the fact that it takes a decade to develop the necessary technology enablers for the next generation mobile communication systems. And we need to start now in order to have something ready by the 2030s. What is 6G? Well, it's many things, and nobody knows yet what are all the things that are there. So we do not know yet exactly what 6G is. We do know some of the basic technology enablers that should be there for the 6G era in 2030s, but we do not yet know how these different enablers will be deployed in a system-wide design. Few words about this flagship program. First of all, it's a national flagship awarded by the Academy of Finland, and it's targeting years 2018. So we have started already almost 3 years ago, and we will still continue 5 more years until the end of 2026. The total ecosystemic volume that we expect to reach in this program is somewhere around 250 million euros. This flagship funding coming from Academy of Finland represents about 10% of this funding. Rest comes from the university itself, and a huge number of different projects that are run with the 6G flavor. Then when we start to look at the program content, what type of research activities do we have inside the research or the flagship program? First of all, we expect to see that the wireless connectivity is going to be, that's when I come from University of Oulu and Center for Wireless Communications, which basically tells us that the wireless connectivity is something that we are heavily concentrating on. And what do we aspire as terms of, for instance, data rate is about 1 terabit per second to be the maximum capacity of the 6G system. So 1000 gigabits per second. And then, as we have already witnessed, that this ultra reliable low latency communications of 5G will introduce millisecond latencies end to end. We have already concluded that this is not sufficient, that we need to take this low latency communications further. So that is the second area of study in the wireless connectivity. How low can you go in terms of latency to allow automatic industrial processes, for instance, self-driving vehicles and such autonomous processes and platforms. So this is one thing. One is high, even go higher in the data rate, and second one is going down on the latency, and not just on the latency. We also need understanding of the timing of the system, so that some industrial processes require exact timing, which means that the jitter when a message arrives should be also controlled down to microsecond level, and that introduces this time-sensitive networking and global awareness of time. And that is sometimes tough bill for wireless systems, since we all know that propagation channel is in wireless communication such that you can, sometimes it's hard to predict when a message will arrive. But mechanisms are being developed how to do that. Now, if we talk about terabit per second, that means that we need a huge bandwidth, right? Now, that brings us directly to the second research area of the flagship, devices and circuits. Since we now think that we need up to 1 gigahertz bandwidth for our signals, we can manage maybe with tens of gigahertz bandwidths, but regardless, such bandwidths are not anymore available at the lower frequencies. Obviously, 6G will entail solutions for lower frequencies, but the hard part that we are currently tackling is going to sub-terahertz communications. And as it appears, the current semiconductor materials cannot provide sufficient power in an effective manner when we go beyond 100 gigahertz center frequency. Therefore, we need to look at new terahertz communication materials, what type of semiconductors are needed there. And second thing that rather directly arrives from this fact is that we need to figure out how to make the circuit designs in this terahertz region, since materials are new, and then we need new processes to make the circuits, semiconductor processes, and new design principles. So devices and circuits, when we go to terahertz communication, is one of the key research areas of the flagship. Third one is distributed computing, or you could claim it to be mobile edge intelligence. And this means that by introducing machine learning, or in more generic terms, artificial intelligence algorithms into your network, close to the users, not anymore into the centralized cloud, but close to the users, you can optimize really fast either applications or also the network functioning. How does the network function? So that can be also be optimized by the use of machine learning. And here we also start to see new type of user devices or mechanisms to consume data, such as this augmented reality, virtual reality, and such things. Eventually, it may lead to a situation when these smartphones of today start to gradually vanish, and we start to see new type of user interfaces into the data pool. And the third area is the services and applications. As I mentioned, one of the areas is how do we see the future services and how do we consume the data. But on the other hand, it also means disruptive value networks. As one can assume that when we go to the higher frequencies, link distances will be shorter. Obviously, it can be alleviated by using a huge number of antennas and such to gain in the propagation loss in such a way that we can go up to maybe hundreds of meters of link distances. However, that always is a costly thing to do. And therefore, most of the 6G high frequency networks are indoor networks. And that means that there might be room for new value networks. The flagship has threefold goal to support companies in finalization of the 5G standard. And we have a 5G test network facility in Oulu. Similarly, there is one in Aalto, one in Tampere, in many places in Finnish universities to support co-creation in terms of how 5G can be used in for instance, industry, or how the 5G could be used in self-driving vehicles, drones, for instance, or shopping malls, hospitals, so on and so forth. The second area, which is the more blue sky and exactly the focal point of the 6G flagship, is the fundamental technology components to enable 6G systems. So we are doing quite a lot of long-term research to find out what are the technology components to be used and how to fine-tune them to fit the 6G bill. And obviously, we wish to find out mechanisms and offer solutions how to make the digital society inclusive digital society, so that we can start to have easy to use and services that are available everywhere in 5G and 6G era. Well, vision is vision, but what it states is that it's data driven. So it means that the data is in the center of it all, and it's near instant and it's unlimited wireless connectivity. So basically what I was just talking about, AI, high data rate, and how to use the data. Some of the numbers of the first 3 years of the flagship operation, we have either part-time or full-time people working for this flagship. It's now 420 people around. 55 doctoral degrees over the first 3 years. As I mentioned, a large number of different research projects are running on top of the Academy of Finland funding, 267 projects over the 3-year period. A lot of publications, and then I will briefly touch the 6G white paper later on in the presentation. And we have written 13 white papers which have received, at the last time we checked, 660,000 downloads. So basically this means that this flagship, as it was the first 6G research program is in the world, is influencing the direction of 6G globally. And for instance, affecting research development and innovation agendas. For instance, EU Horizon Europe program has adopted many of the principles and the ideas from these white papers. And to mention one more thing in terms of collaboration, we have started this HexaX Horizon 2020, last of the Horizon 2020 projects, which is deemed to be the first European project to define the technology components in 6G in terms of European understanding. We have been involved since 3G period in these European defining projects. For instance, 3G was defined by Frames project, 4G by Winner projects, 5G was defined if FP7 Metis project, and now this Horizon 2020 HexaX projects is deemed to be the one that provides the European view of 6G building blocks. Now, well, there are challenges. I mostly said what is in this slide already, but I will skip and take a look at these. Up to 4G, the human and the needs of the human were in the focal point of mobile cellular communication. We use voice, we download videos, and it's all about human consumption. So human consumption of data. 5G and 6G era obviously is targeting not only humans, but including machines, processes, and autonomous things. And that means that the vertical industries, may it be banking, energy sector, in manufacturing industry, sports, you name it, those are driving the development in the future. That means that network architectures should be fitted to, let's say, fulfill the needs of these verticals. And there is the second trend due to the fact of these lower link distances and indoor networks that the network architectures will change. New value chains appear. For instance, we have been pushing this local operator paradigm already since 2015. And for instance, this 5G test network that we have here in Oulu and similarly what is there in Aalto is basically a local operator system. So basically, we are an operator, but only locally. So that is something that will appear in 6G, already in 5G, but also in 6G era. One of the things is that more than 3.5 billion people are still unconnected, no connection to the internet whatsoever. And that is one of the key, let's say, targets for 6G, connecting the last billions. And that is basically a versatile problem. It includes the satellite and non-terrestrial component, but also local community networks and many different solutions that could offer these internet services to all. So basically, digital inclusion is at the heart of the development of 6G. Autonomous wireless systems, as I mentioned, these latencies need to be still pushed down so that we humans are rather slow. I mean, our response times are in few milliseconds if we talk about touch, tactile internet, and other senses are even slower. So machines, on the other hand, can operate in the microsecond and even nanosecond domain. So we need to develop these systems using these new capabilities provided by these wireless connectivities. And as I mentioned, we are in the brink of requiring new materials, new circuit designs, and new factorization processes for semiconductor circuits. So technology leap is required. We published in 2019 the world's first white paper, and it's been downloaded already, I don't know, 350,000 times, and it gives a lot of research questions for the academic community. What type of research questions should be answered when developing 6G? And it states that the research vision is based on three cornerstones. Really bringing in the data to the heart of the system. Second thing is that we need to include sustainability, United Nations Sustainable Development Goals as heart of the key value and key performance indicators when developing a 6G system. And then it's all about value networks changing. So numerous business and societal players together create the new 6G infrastructure products and services. Now, last summer, we provided 12 new white papers. And if you are interested in more detailed, let's say, discussion and description of the what type of components, elements, what type of business models, what are the drivers of 6G, how to use edge intelligence in 6G, what are the broadband connectivity solutions for 6G, and so on and so forth. What are the RF parts of 6G? So these white papers prepared as a collaborative action within a community of 250 participants from more than 100 organizations, describe in more detail. I will have few examples of the solutions provided by these, or suggestions provided by these white papers in the slides, which are still coming up. But if you are a 6G enthusiast, I propose you to go either Jultika Oulu or 6gchannel.com, and you can find these white papers there. And if you wish to study, please take a look at those. So I already mentioned that the data consumption and new device forms will appear. Smartphones are likely to be replaced by some kind of XR experience, maybe even wearable systems. And displays in cars, for instance, can be embedded in the glasses of the windscreen and the side glasses of a car, and so on and so forth. So basically what we start to see is that the environment that we live in is providing us the human machine interfaces, or the displays that we are foreseeing. Obviously that this does not happen today, tomorrow, not in 2 years, not maybe even in 5 years, but in 10, 15, 20 years, we start to see these kind of things happening. I already discussed this local operator paradigm, and it mainly comes from the fact that transition to higher frequencies and the increasing role of indoor networks will boost the requirements for network sharing in cities, indoor spaces, and drive this local operator paradigm. For instance, a factory, for instance, Nokia factory making base stations, would like to have really secure, really low latency network within their factory so that they can control the environment down to the last microsecond, so that they can pull everything out of the resources in the factory. And they can put, for instance, let's take, for instance, robots. Most of the things are, well, at least, for instance, Nokia Oulu factory, all the base stations are already assembled by robots. Humans are only in a supervisory role. So they are looking on top of that everything goes as is supposed. So if we take, for instance, robots and take the brains out of the robots themselves and bring it to edge computing server, which is at the factory, then you can have collaborative robotics algorithms running in the edge cloud, and makes your assembly lines after that really easily changeable. So if there is some product change, you don't have to go into every robot and basically reprogram them or whatever they do, but you can only change the algorithm within the edge computer, and then again your robots will collaborate in a new fashion. Just an example. Another one is quality control. For instance, you have cameras which are looking at the printed circuit boards, and they can immediately see whether there is something wrong by using machine learning and video analytics. So a lot of these kind of things which are local and which are required at the facility will drive this change. Stakeholder roles will change. One of them is this micro operator, but there will be other type of operators and stakeholders. For instance, security providers, data brokers, different kind of context will appear into the network. But most of the players already exist. They may just change their focus a little bit, but new ones also will appear. Now, if we take a look at the initial key performance indicators, KPIs for the 6G, this is what is now available, and these are even being changed a little bit since this white paper was developed where these numbers are. So up to terabit per second peak data rates, 100 microsecond radio latency, so it means redesign of the frame structures. For machine type small scale devices, 20 years battery life. 100 devices per cubic meter, 100 radios per cubic meter, so the density should be high. I mean, where would you see this? Well, not everywhere, but for instance, a car could be an environment where everything is operated, every switch and every bolt, everything is controlled and operated by a small radio. There's a sensor, there's an actuator. You could see 100 devices per cubic meter. The traffic increase in the networks is approximated to be 10,000-fold, so 4 orders of magnitude more traffic. The link budget needs to be plus 40 dB in some applications, for instance, agriculture, where the link distances might be really, really huge. And then this extreme ultra reliability. Nowadays, people talk about 9 nines. So 99 point and then 7 nines. So 1 in 10 million outage. So one message out of 10 million is allowed to go waste. And that is, if you divide that into time, it's and think about link down times, it boils down to seconds per year. The energy efficiency is key. I mean, ICT systems already nowadays consume huge amount of energy. How to make energy efficiency one of the key targets is a good question. Smaller link distances and renewable energy generation might be some of the solutions, but also we need to take a look at the architectures and how those support energy consumption reduction. And the positioning, here we have 10 centimeters indoor. However, people are already talking about less sub-centimeter positioning accuracy indoors, and outdoors, give or take 10 centimeters. So these kind of generic 6G targets are presented currently in different fora. Okay, I mentioned this already, that there will be new, for instance, new materials, indium phosphide. It already exists as a material, but how to make that kind of semiconductor material perform very efficiently? How do you make circuits on that, and so on and so forth? And there are other interesting, for instance, there have been some developments, for instance, building lens antennas out of cellulose. Go figure. Now, the wildest guys in 6G, for instance, Nokia is promoting an idea. So when you have a radio link, you have a transceiver, well, let's say transmitter and receiver, so basically 2 transceivers. And these transceivers, one might be base station, one might be some kind of a user device, maybe augmented reality device, maybe car, maybe something else, that these transmitters and receivers, using artificial intelligence or machine learning, decide what is the best way to transmit data. So what is the air interface solution for that particular application and environment? Will it happen? In some degree, definitely. Whether it will be fully automatic, we'll see. We shall see. New grant-free access methods are critical. I mean, we start to have these massive machine-type communication and networks, 100 devices per cubic meter. We cannot anymore assume that we have scheduled transmission of all the data. We need to have some kind of grant-free access so that you don't have to use huge amount of bandwidth for control resources. Since many of these machine-type communications only occur seldomly, but on the average, they would consume huge amount of the control plane capabilities. Signal shaping. What about analog modulation technologies in 6G? And one of the key issues we always hear in discussions is the security. We can build security also in the transmission path of the physical layer by using either coding or noise-like signals and things like this. 6G networking, this is not really my area, but anyway, this again targets the privacy, trust, and it has been proposed that instead of IP address, devices will be given IDs which are basically non-fakeable and basically with 100% identifies the device, and if it's malicious, you can then discard it. So it cannot anymore connect to the network. So we can somehow figure out ways how to get past this spoofing and cyber problems. Then what will happen is that we start to see the usage of this 6G signal, not only for communications, but also for sensing and imaging. Now, in high-end 6G devices, we may have in the beginning 1,000 antennas, 10,000 antennas. Some people talk about already 1 million antennas. Since we go high in the frequency, the lambda per 2, so basically the antenna separation becomes so small that you can pack in an area of 5 by 5 huge number of antennas. And it starts to resemble the CCDs of your cameras, operating on radio frequencies rather than visible light. But hey, what it is, basically it's a camera. So radio frequency cameras. So imaging using radio frequencies is becoming integral part of 6G systems. And it can be used for sensing, for instance, radar type applications, and even looking through, for instance, smoke for firefighters, for instance, and so on and so forth. So a lot of new things happening. Just picked few of those, not really have time to go through many of these. But then a couple of words about this test networking and the need for experimental environment in the future. The networks are becoming so complex that it's hard to do full-fledged analysis on papers or with simulations. And you need to start to have these test network to be able to test new application services really fast and in a realistic environment. Few words about our test network at the University of Oulu. You can see here a huge number of devices, different frequencies. We have technologies, LTE, narrowband IoT, LTE-M, ultra-wideband, Bluetooth, 5G, LoRa. Most of the air interface technologies are integrated into this environment. And what is the status of the environment? Well, it's a smart campus local operator. And we are an operator, similarly to ELISA or for instance, DNA or Telia. So only operating in certain regions locally. One of the interesting things was that we helped Nokia in in the development of a millimeter wave base station. And this was demoed in EU Korea project by Horizon 2020 in the 2018 Winter Olympic Games, so that our 5G TN was connected to a counterpart owned by a research institute ETRI in the Olympic village, and then we were exchanging information and, for instance, showing the aurora borealis for the Korean people, since we know that Asians quite often like aurora. So what is a test network? It's a co-creation platform. So there might be a company which is looking for applications or digital services, and they want to develop and try it out in a real environment. It could be, for instance, companies like Keysight, which are developing measurement equipment, and they wish to start to use our environment to test, okay, what type of measurement devices in the future are required. We have done millions of integrations. Well, million is quite a large number, but many integrations of 5G devices, different platforms, may they be drones, forklifts, cars, excavators, and try to make them remote controllable. That's something that we've done quite a lot. Even harbor cranes. Digital twins have been developed, for instance, for Oulu Harbor, so that you can see in real time the data which is generated within the harbor, and in its 3D model you can see who's moving, where, why, so on and so forth. So it's a co-creation platform, and since we are now in the 5G era, obviously we only have some, let's say, really proof of concept or prototype 6G devices available at the moment. But as time evolves, we wish to change this 5G test network to 6G test network. Here you can see your typical architecture of a mobile cellular system. So you have in the center of the picture, you have the core. Now we have both the 4G core, the enhanced packet core or EPC, but we also have the 5G standalone core to support 5G services in a standalone mode. Obviously, this 4G core is used for the 4G and 5G networks in non-standalone mode. Then we have these edge computers where you can bring in the services or the network optimization tools so that you can take a look at your network performance and try to optimize it, or offer a service right at the edge of the network, offer knowledge for the users right at the edge of the networks, and so on and so forth. And these test networks are connected to for instance, to Tampere and Aalto and VTT networks. So we are basically a nationwide system nowadays, and these are used in different sites and also in tests between the sites for developing new type of solutions and services. Now, yet another reason why bother with an experimental test network. Well, answer is versatility of vertical requirements. We already discussed these verticals. If we take a look at, for instance, industry enhanced URLLC, you can see that the latency requirement, for instance, is 100 microseconds, and jitter control 1 microsecond. Then again, if you take, for instance, eHealth, higher data rate, smaller latency requirements, jitter control, fine, lower densities, and so on and so forth. So how do we satisfy the needs of these different verticals? This basically says that one size fits all networking solution in 6G time isn't sufficient anymore, but you need a lot of flexibility in the system design so that you can basically allow for these local micro operators appear and allow them to be, let's say, vertical specific service provider. So there might be a operator which comes into the play, and it could be a global operator offering, for instance, energy utilities, networking services in such a way that it's optimized for energy network usage. Similarly for agribusiness or self-driving vehicles, so on and so forth. So how do we facilitate service pool and avoid technology pools? This was one of the mistakes of 5G. ICT guys develop a technology, try to push it into the vertical. When the real need might not be served, and therefore we need to figure out with the vertical players what are the service needs, use cases, and introduce this service pool and avoid the technology push. Yet another slide on the same topic, figuring out this local operator paradigm and how to do it in real fashion, in real world is an interesting question. For instance, how do we do spectrum regulation in the future? Can we devise algorithms and methods to, let's say, give local frequency licenses on the fly, given the traffic needs, given whatever is happening in the localities, so that whenever there is a service need and there's a service provider that can negotiate locally their frequency licenses, for instance. And this is something that you cannot emphasize enough. These United Nations Sustainable Development Goal has been introduced by us to be really taken into consideration in 6G network design. And we have a strong belief that we can affect many of these SDGs through ICT systems when deployed in such a fashion that they are taking into account the need to improve on these different SDGs. It might be related to capacity, it might be related to coverage, it might be related to digital inclusion. But anyways, this is something that we need to bear in mind when we are developing 6G systems. Well, this is just to say that in Horizon 2020, the European Commission invested in phase 3 of the 5G programs 190 million euros to build in the Europe these test facilities. Finland is obviously one of those. And now there is a process ongoing to build the next generation pan-European ICT testing facility. And currently what we have is 15 countries have submitted a proposal to ESFRI, which is a research infrastructure body of the European Union. And one example you might know is this CERN, this nuclear research facility in Switzerland. So we wish to be included also in the ESFRI together with 15 European member states and the partners within those countries, so that we really would have a good pan-European platform. Oh, and then marketing slide. We are going to organize the PIMRC 2021, basically in Helsinki, but we decided still, even though the COVID-19 situation is improving, to go for fully virtual representation. And anyways, this happens between 13 to 16 of September this year. So that if you are available, somehow wish to join, be please bear this